All right, let's dive into something that sounds like it's straight out of science fiction, but it's not. It's actually a real phenomenon that's about to change everything, from the phone in your pocket to global security. We are talking about quantum tunneling, a paradigm that promises both perfect security and a world with absolutely no secrets.
So just to kick things off, let me ask you a question. What if you could just walk straight through a solid wall?
I know, sounds totally impossible, right? Well, here's the crazy part. In the bizarre world of quantum physics, stuff like that happens all the time. And no, this isn't a movie plot. It's a fundamental rule of our universe, and we're just now starting to figure out how to use its incredible power.
Okay, so let's get into the nitty-gritty. How does this quantum ghost effect actually work? To really get a handle on it, we've got to start with the science.
The official name for this is quantum tunneling. At its heart, it's what happens when a tiny particle, like an electron, does the impossible. It passes through an energy barrier that it shouldn't have enough energy to get over. Now, how can it do that? It all comes down to one of the weirdest ideas in all of physics: wave-particle duality. The idea that tiny things can act like both a solid particle and a spread-out wave. And that wave-like nature, well, that's the secret sauce.
To really get it, think about this comparison. In our everyday world, the classical world, if you throw a ball at a wall, it bounces back. Every single time. It's simple, predictable. But a quantum particle is a whole different ballgame. It acts more like a wave hitting that wall. And while most of that wave reflects back, a tiny little piece of it actually leaks through and appears on the other side. That means there is a real, measurable chance that the particle just popped through to the other side.
Now, this isn't just some random fluke. It's actually a predictable phenomenon, and it's governed by some very specific rules. You can see a few of the key factors right here. The heavier a particle is, the less likely it is to tunnel. That's why electrons do it easily, but you and I are, stuck walking through doors. Also, the thicker the barrier, the harder it is to get through. Makes sense. And finally, the bigger the energy difference between the particle and the barrier, the lower the odds. The really cool part about all this, it means we can actually engineer this effect. We can control it with incredible precision.
So, what do you do with an effect like this? Well, for decades, tunneling was actually a huge pain for engineers. It was just an annoying glitch, a sort of leakage current in transistors. But now we're flipping the script. We are deliberately harnessing this impossible effect and turning it from a bug into a killer feature.
And the applications are just mind-blowing. We're building something called tunnel field effect transistors, or TFETs. These things could lead to devices with incredible battery life. We're talking IoT devices and satellites that sip power. Why? Because the electrons tunnel through a barrier instead of having to be forced over it. Then you have quantum computing, the very heart of the qubits that Google and IBM are building, these things called Josephson junctions. They work because of tunneling. And this is the principle behind a whole new class of quantum sensors that can, and I mean this literally, see the unseeable. Being able to control tunneling is a total game changer for security and precision.
And that brings us to one of the most powerful uses for all of this: creating a new kind of unbreakable code, a new shield for our entire digital world.
Okay, get this. The very same quantum tunneling effect can be used to create what are basically unclonable silicon fingerprints for our devices. Imagine every single chip having a unique identity that's physically impossible to copy.
This incredible tech is called a physical unclonable function, or a PUF. See, when a computer chip is made, the ultra-thin oxide layer inside a transistor has tiny, random imperfections in its thickness. We're talking variations of just a few atoms. Tunneling currents are extremely sensitive to these tiny differences. A slightly thicker spot means less current tunnels through. A thinner spot means more. So by measuring these unique current patterns across the chip, you can generate a long string of ones and zeros, a cryptographic key that is physically tied to that one specific piece of silicon. You can't clone it because you can't perfectly copy that random atomic-level structure.
As Shahram Masaibi, the CEO of Crypto Quantique, puts it, we could produce unclonable randomness from each transistor, enabling us to produce cryptographic keys and safe device identities directly linked to the DNA of the device. Think about that. The security isn't just software anymore. It's baked right into the physics of the hardware itself.
But here's the thing about technology. Every shield can be reforged into a sword. So let's pivot and look at the flip side of this coin, the potential end of stealth.
Because that exact same incredible sensitivity that lets us create perfect secrets can also be used to make everything visible.
Welcome to the new world of quantum sensors. We're talking about quantum magnetometers that could spot the faint magnetic whisper of a submarine deep underwater. Quantum gravimeters that can map hidden bunkers and tunnels from the sky by sensing tiny changes in gravity. There's even talk of quantum radar that could render stealth aircraft completely visible. And quantum RF sensors so sensitive they could eavesdrop on the weakest radio signals. In a world with these sensors, where exactly do you hide?
And look, this isn't just theory anymore. This is happening right now. In a recent field test in the UK, scientists took one of these quantum gravity sensors out to a normal road. It started measuring tiny variations in the Earth's gravitational field. Suddenly, it picked up a little dip in the gravity signature and successfully mapped a hidden tunnel buried just half a meter underground. It's like having X-ray vision for the entire planet.
The strategic implications of this are just massive. Whichever country is the first to really get these technologies working at scale could effectively erase the concept of stealth, an advantage that has been a cornerstone of military strategy for decades.
So if we can see through the ground and detect invisible planes, what does that mean for us, for our personal privacy? This is where we have to talk about the human cost.
A recent analysis on this subject had a quote that is pretty chilling. It said, "These technologies could enable humans to, quote, see through barriers, around corners, and potentially into the body or mind." Just let that sink in for a second. That's a fundamental change in what it means to have privacy.
And the risks are very real. We're talking about through-wall surveillance that makes the privacy of our own homes a thing of the past. Biometric tracking that can identify you from a distance just by the unique electrical signature of your heart without you ever knowing. In a world blanketed with these sensors, real anonymity could just disappear. Some experts are even warning about the possibility of brain wiretapping, detecting the faint signals of your own neurons from outside your body.
So, naturally, this has kicked off a massive global race. This isn't just a science project anymore. It's a strategic necessity. China has taken an early lead, deploying quantum networks and even a dedicated satellite. In the US, DARPA is working hard to turn these scientific principles into real-world, deployable systems. And India has launched its own national quantum mission, determined not to be left out of this critical technological shift. And a huge part of this race is happening right above our heads, in space. The market for satellite communications is expected to absolutely explode, jumping from about $90 billion today to almost $160 billion by 2030. Why the massive boom? Because satellites are the perfect way to build global quantum networks, beaming unhackable encryption keys down to anyone, anywhere on the planet.
So, when you boil it all down, you're left with this incredible paradox. Quantum tunneling, this one single phenomenon from the quantum world, gives us the power to both perfectly hide and to perfectly reveal.
It offers us the dream of unbreakable security on one hand and the nightmare of the complete loss of privacy and stealth on the other. So, as we stand here, right at this crossroads of incredible promise and serious peril, the real question isn't about the technology, it's about us. Which path are we going to choose?